So today we're going to work on 3.6, area and perimeter. I've chosen two problems from your homework, page 27, number 1, and page 32, number 4, area and perimeter of a trapezoid, area and circumference of a circle. So we'll start up here. Area of a trapezoid. First of all, we need a formula for the area of a trapezoid. It is the average of the bases, base sub 1 plus base sub 2 divided by 2 times the height. Sometimes our textbook will call it half base 1 plus base 2 times height, and again, that's just another way of writing this formula. So here we'll identify each of those parts. Base sub 1, typically the smaller of the two parallel sides of a trapezoid, is 5. Plus base sub 2, which is 8, the longer of the two parallel sides of a trapezoid, divided by 2, times our height. And our height here is not a side of the trapezoid, it is the perpendicular distance between the bases. So that's going to be 3. A little bit of math. 8 plus 5 is 13. 13 divided by 2 is going to just be 13 halves for just a moment, and we'll multiply that by 3. That will give us the area. So 13 halves times 3, or 3 over 1, would be 39 over 2. This is a two-dimensional unit of measure, so we'll call it centimeters squared. And I could come up right here and write 39 over 2 centimeters squared for the area of the trapezoid. If I wanted to change it into a mixed number instead of an improper fraction, 2 goes into 39 19 times with 1/2 left over, and 19.5 centimeters squared would be the area of that trapezoid. We could also write 19.5 if we wanted to convert it to a decimal, but the improper fraction, the mixed number, or the decimal version are all fine with me. Next, we'll do the perimeter. Once again, we need a formula for perimeter. The perimeter of basically any two-dimensional shape is just add up the side lengths. We could give it a more formal, more fancy textbook definition for every individual polygon, but add up the side lengths is enough. So we're going to go ahead and add 8 centimeters, 5 centimeters, 5 centimeters, and 3.2 centimeters together to come up with the perimeter. Notice the height is not used when finding perimeter. So once again, side 1, side 2, side 3, and side 4, 3.2. I'm going to use a little mixture of the commutative property and the associative property to help me out here. 5 and 5 is 10. 8 and 3.2 added together is 11.2. So I have 11.2 and 10. 11.2 and 10 is 21.2. 21.2. And this is a distance. It is still a first-dimensional unit of measure, so we're in centimeters here. Perimeter is going to be measured in centimeters, area in centimeters squared. I encourage you to check all of my calculations on a calculator or on paper by hand, because I'm doing them all in my head as we speak. Okay, moving on to page 32, number 4. This is area and circumference of a circle. Remember, when we find a perimeter of a circle, we call it circumference. The formulas I'll be using are area equals pi times radius squared. Circumference is pi times the diameter. We could also call it 2 times pi times the radius. Again, the commutative property would let us see that twice the radius is the diameter. So either one of those work. I'll use these because I have them memorized. I have a little saying that I learned long ago from some other teacher. Cherry pie is delicious, apple pies are too, and that helps me remember them. Okay, so area first. Area is pi times radius squared. Well, the radius is not 16 feet. The radius will be half of that, or 8 feet. So the area is going to be pi times 8 squared, which is pi times 64. But in order to write it correctly, it will be the coefficient first, the constant second, and then our unit of measure. Again, this is a two-dimensional unit, so we'll call it feet squared. I'm going to leave my answer in terms of pi. So my area is going to be 16 pi feet squared. That's the exact answer. Nobody else on the planet could give us a more precise answer than this. If I had a calculator on me right now, which I don't, I would go ahead and perhaps estimate pi by 3.14 and then continue on to get a decimal approximation. But anytime we take pi and use 3.14, we've now ruined the perfection of our answer. This is now an approximation that we would round to the nearest hundredths place, perhaps, because pi was rounded to the nearest hundredths place. Please recall, pi is an irrational number, which means it has a non-terminating, non-repeating decimal. It's 3.14, 159, 26, blah, 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 and it never stops and it never forms a pattern. It's a non-terminating, non-repeating decimal. Enough said about pi. Circumference. Circumference is pi times diameter. So, I will write circumference equals pi times, my diameter was 16 feet, and there, I'm finished. Except I'm going to write the coefficient up front and the constant second. And 16 pi, again, this is a distance around the circle. Distance is a first dimensional unit of measure. So I'll come over here and I will write 16 pi feet. I think I made a mistake here. That should be 64, shouldn't it? Uh-oh. I only filmed these once, so if I make a mistake, I've got to catch it right here. 8 squared should be 64. That should have been 64 times 3.14. And perhaps you caught me while you were watching this. I made a mistake. Area is pi r squared. Pi times the radius squared, 8 squared, should have been 8 times 8 is 64 pi. My bad. Definition of a math teacher. Says A, writes B, means C when the answer is D. Yeah. Okay, so what do we have? We have area 64 pi feet squared. Circumference is 16 pi feet. And again, if we wanted an approximation, we could jump down here and write 16 times whatever you want to round pi to. Usually for achievement tests and SATs and ACTs, it's 3.14. And then again, it would be feet. So check that answer on the calculator. That will actually be the answer on your worksheet answer sheet. But I don't have the calculator on me. Okay.